In the previous videos, we saw that whenever an electron absorbs an energy, it jumps, correct? In the sense, here we are talking about a phenomenon called as excitation. See, excitation is what? Excitation is that phenomenon where an electron absorbs an energy and jumps from lower to higher energy state. This is what we call as excitation. This phenomenon is called as excitation. Now, see, excitation energy. Suppose if you are trying to figure out what it is, it's very simple. The electrons are being excited. For that, we need to give some amount of energy, isn't it? Like say, if I have to jump from first orbit to the third orbit, some amount of energy is required. How much of energy is required? That is basically excitation energy. Now, mathematically, we can easily calculate it. Okay. Now, we know what is E1, that is energy in the first orbit, and the energy in the second orbit. If we subtract these two, that is, if we do E2 minus E1, this is going to give us the excitation energy. So, if we have to do E2 minus E1, so as you can see, this is the energy what we have to give. Okay, if so much of energy is given to an electron, it jumps from the first orbit to the second orbit. Now, directly we cannot give an energy to an electron, but we can put that particular electron within that potential difference, correct? So now we come across another term called as excitation potential. So when we say excitation potential, how much of potential difference has to be given to an electron so that it jumps from one orbit to another orbit. See, when I say one orbit to another, it is always from lower to higher. That's when we say it is being excited. Okay. So we come across excitation, that's the phenomenon. Okay, where you jump from lower to higher orbit. Then we have excitation energy. How much of energy do you have to give? Then excitation potential, in the sense by what potential difference or by what potential you have to raise the electron. So we have three things. Now just imagine, suppose you're giving energy to an electron. Okay, some energy you get, it excites. Let's say it went from first orbit to second orbit. You give more energy, it jumps to the third. Keep on giving energy. So 4, 5, 6, 7. Let's say you give so much of energy that it just gets knocked out of the orbit of that particular atom. In the sense, here the atom which was neutral now is being ionized, correct? So we come across another phenomenon called as ionization. So ionization is that phenomenon where the energy is given to an electron so as to the energy is given to an electron so that it gets knocked out of the orbit. Okay, this particular phenomenon is called as ionization. Alright, now for ionization, again we have ionization energy, meaning how much of energy we have to give for the particular electron so that it just jumps out of the orbit. Okay. See, if it is jumping out of the orbit, it is going away from the influence of the nucleus, isn't it? So if it is going away from the influence, it has reached the state of n is equal to infinity, where it has an energy of 0. So if you have to move from the first orbit all the way till the last orbit, that is n is equal to infinity, then what we do here, again we subtract. See, when you subtract, this is what we get. See, for the first one, 13.6 electron volt. So much of energy is required. So much of energy, 13.6 electron volt of energy is required so that an electron in the first orbit just jumps out of the orbit. In the sense, it does not come back. Alright. So we have ionization potential. The same thing, by how much of potential we have to raise so that the electron jumps out of the orbit. Clear? So these are the two phenomena. One is excitation, one is ionization. See, the difference between these two is that excitation, if we are talking about the phenomenon of excitation, electron jumps but it returns back. But in ionization, the electron jumps and it just flies off the orbit. It's not going to come back. This is the major difference between excitation and ionization. Alright? So once you talk about this excitation and ionization, see, Bohr's postulate and the Bohr's model, what we have, it clearly gives what is the energy required, correct? And how much of energy, the difference we have. So Bohr's model could explain all these things. So we saw so many advantages of Bohr's model. We saw how the spectral lines are being, how are they originated. And we also saw the energy level diagram, correct? And we also saw we have a stable orbit, and how Bohr's postulate and this one, de Broglie's hypothesis, how these two go hand in hand. So we have so many advantages of Bohr's model, but then every model has one or two limitations also. So in the next video, we will look into the drawbacks of Bohr's model.